Because if it's a proxy, then when they get the answer back, they'll just rewrap it and just pay for it.
But they have to keep track of the connection. Right, so have a full connection mapping anywhere, so they already know whether these students here.
Okay, so that's reasonable. I understand. That's why I spent late time today. It'll come on the mailing list. No one will understand. It's just going to sit not working.
I agree that we shouldn't be talking about
It's not on,
songs.
it's not on the agenda.
Right.
If he's here and he comes up, I think, which, and there might be something, I think it's fine to say.
I think if
Thank
we
you
talk
for
about it during
telling us.
the recharter section,
Right.
it comes up.
If we're wrong, we say thank you for telling us about this. Clearly, this is not very good to discuss at night because nobody's had a chance to. So this is going on here, speaking during work is the last call next. Because literally, they thought of this in less than 24 hours. Okay. This is not my client is not a good place to do that. And by the way, when I say I thought of it, I mean, I just.
Okay, you could have waited today. You could have waited today.
I actually considered that, and then I was more worried that they would continue with what their original idea was, which was.
Hey, y'all, even though it's starting time right now, we're still having a little AV trouble, so we're waiting to get this sorted out before we begin.
Do you want to? Well, I'm attempting to be the presenter, but
It's not clear that it's a matter of your laptop, though.
no, it's not clear at all.
And I was going to actually install, and I did not get to it, some PDF presenter software, because normally PDFs are annoying just scrolling through, but some people actually have written presenter software for PDFs, but I didn't get to decide which one wasn't a virus infecting the machine. Yeah. Is it possible that it's a laptop issue and not the interface bus? Oh, okay. Using, yeah. You did. Okay, great. Yeah, Suzanne needs a spot by the mic, please. Maybe. Suzanne's going to be our jabber scribe, and we still don't have a minutes taker. So somebody please step up before we start pointing fingers and drafting people.
Well, yeah.
Yeah. Yeah. Right.
Well, if necessary, we can ask everybody to pull up the materials
Right,
on their
yeah.
personal devices if all else fails.
Yeah.
That one is only for the remote.
Right, is only showing that if there's somebody waiting in line to speak. The other one is actually where all the presentations happen.
And we can see that here.
Right.
that would.
Yeah, I
be
mean,
fine with me. It would just cut out the remote participants from being able to see the slides, but they can follow along on the website.
yeah,
That would be fine.
yeah. Okay, so the AV crew is working to actually hotwire the presentation laptop directly to the projector, which will mean that you people who are on remotely wouldn't be able to see the slides, but they are all uploaded to the data tracker, and so you can follow them there. And while still looking for a minutes taker, Mr. Aaron Falk, I see you sitting in the audience. And apologies that I was not able to make it to TAPS yesterday. Yes, but I have done it many times for TAPS, and even though I could not make it this week, I believe that I'm owed one. So can we take that as a yes, Aaron? Thank you, sir. And so as we are getting closer to starting, although the note well is not up on the screen, you are all at this point no doubt very familiar with it. And as usual for IETF working group meetings, it applies here. I don't think if anybody has any agenda bashing items, we're happy to discuss them, but the main plan right now is to start with Stefan's report on how the hackathon went, and then listen to Paul and Patrick give their update on the current status of the draft and the future direction. And then we will have a brief discussion, hopefully, of the possibility of rechartering if we could have more, if we were to have more work group items. And then finally, Daniel Kahn Gilmore will talk to us about the general issue of how do you trust your DNS data. Stefan, would you like to start even without slides?
Or they can do.
I think the AV cable might be on the way. So. Keep a pause.
Might be able to do the projector and the screen just for now.
Okay.
Okay, I can see my slides, so it's okay. Stefan Bartsmeyer from AFNIC. So at the hackathon, there were around 6 people working on the DO, DNS over HTTPS, which is a large group for the hackathon, and it shows that there is a lot of interest about DO. We have today 5 public DO servers. Well, 3 are more or less in production and 2 are very experimental. Meaning they work from time to time. An interesting thing is that they all use a different server software. So there is already a lot of variety of software. 4 server software are publicly distributed, 5 or 6 on the client side, written in every language, Python, C, JavaScript, Perl, no matter. On several libraries, well, you will see everything if you want on the GitHub of the IETF Hackathon. Next. So basically, the results are very good because everyone is able to talk to each other. I cannot say that I'm surprised because DO is something which is very simple. We already know the DNS wire format, just put it in HTTPS. Not a big deal, so I'm not surprised that it works. When you want
Excuse me, Stefan?
Yeah.
Are you aware that there are no slides up on the screen?
Yeah. Yes, he is.
Okay.
But I can see my slides, so you don't matter. I can see them.
Oh, that's
It's a bit more difficult when you want to integrate Do in some libraries, not because there is some specific problem with Do or with the draft, but many DNS libraries were written with some assumptions about how the transport will work. For instance, assuming that there is a socket available and you can just pass a socket as a handle to a transport. So these libraries will have to be reorganized for supporting Do as a possible transport. And also, as we have seen, if you read the mailing list, many things are not perfectly specified. They may be obvious for some people, but not for others. For instance, people who come from an HTTP background, for them, some of the possible status code are obvious, but they are not if you come from the DNS. So basically, I will not repeat all the things that were discussed on the mailing list, only those that were very apparent at the hackathon. The problem of get, post option, for instance, yeah, Suzanne?
From the Java room? Wow. I'm not sure this microphone or yours are working. Okay. Not clear from the Java room that yours is, though. Do you need to get closer? Okay. Thanks.
Okay, so the problem with HTTP methods, for instance, nobody talked about options when we discovered that by default the JavaScript client tries the options method. Also, some servers support only post. Some clients were written with the assumption that you could always use get. So this sort of problems. There was also the problem of caching. One of the existing servers sent the expires header. Others send back cache control, some with the max age deduced from the DNS TTL. Some are lazy and just return no cache. And also there is a more general problem on when there is something wrong, what do you report on the HTTP side? For instance, if there is a DNS problem such as refused, surfed, etc., do you translate it into a HTTP response code, or do you return 200 and let the DNS client pass the result? So that basically the things that we discovered that were important during the hackathon. Of course, it's not the complete list of problems. Next, I don't think there is a next one. So, okay, any questions, remarks, contradictions?
Paul Hoffman, I want to emphasize that we, the document authors, learned a heck of a lot from the implementations over the hackathon. Unfortunately, we were learning them during the hackathon. I thought I was actually going to see London over the weekend, and that was wrong because the hackathon was very useful for us elucidating some of the questions that came up on the list, and hopefully you will see the answers to those in the next draft. But just as a general thing for people who go to hackathons, if you go to a hackathon to implement a draft, yes, send things to authors. It was really, really helpful.
Yeah, that's the point of hackathon.
Mark Nottingham. Yeah, I think the whole get post duality is going to be something the working group is really going to need to work through and specify more tightly. But the thing that confused me, you mentioned options. Why were people trying options?
Someone, yeah, here.
Was it a course request?
Client, so we can talk about it.
Okay, it was okay. Thank you.
Sure.
Tom Pusateri. So I posted a link to a GitHub project, but basically when you send a post with that MIME type, it will do a pre-flight request to try and decide if the server should respond. And so it sends the options first, and if the server doesn't respond to the options, or in this case it responds with a 404, then the post never gets sent, and then you can't get the response back.
I can also add, I said that it was a JavaScript problem, but actually a JavaScript in the browser problem. Node.js does not have the problem.
That's correct. I posted two projects. One, it runs in Node, and so this isn't a problem, and one, it runs in the browser through Webpack, and so it is a problem. But it shows that you can try both of them, but
Pat McManus, Mozilla. I can elucidate a little bit. I actually don't think this is a problem. I think this is a successful execution of a feature and an explicit goal of the document. One of the goals of the document was to enable JavaScript-based, content-based applications to be able to participate in DOE, right? Consistent with the web's same origin and cross-origin security policies, right? And that's exactly what we're seeing here, which is really great. So what you're seeing is more or less a side effect of applying those security policies in a JavaScript context, and someone deploying a server that anticipates cross-origin traffic from a JavaScript application needs to understand that, and that is all actually encapsulated at a level like above DOE, because once you cleared the pre-flight, you know, the DOE specification was then in effect, and the purpose of the pre-flight is to actually make sure that you don't speak any other specification until the pre-flight is cleared. So it actually is a separable concept.
Tom Pusateri, yeah, I didn't mean to make it sound like this was a problem or an error in any way. The browser's doing the right thing, what it's expected to do. But if servers want to respond to these kind of requests, then they have to handle the option. And that may be something that needs to be put in the spec.
Okay, thank you, Stefan.
Tony Finch.
one more.
There's been a bit of discussion on.
A little closer
Sorry?
to the mic.
Okay. Tony Finch. There's been some discussion on the mailing list about maybe some non-normative advice to implementers about how to do HTTP right in this context. And I think so far we've been talking about response code, status code, I mean, and extending that to cover options as well would probably be worth doing.
Okay, great, thank you. And so as you can see, the AV guys are almost all set. So before we move on to the status of the draft, who Paul is presenting, Patrick's presenting. Patrick, yeah, we'll just let them get this sorted and get your slides up.
Okay. And for the avoidance of doubt, please note well that you are at the IETF and IETF rules apply. Yep.
All righty. Welcome to working group session number 2 of DOE to talk about the DOE protocol draft, hopefully the final session. Next. All right. The road behind and the road ahead. So last meeting we discussed 01, an 02 came out. An 02 came out of that fairly quickly, thanks to the feedback we received in the room. A couple months after that, enough list discussion had happened to trigger an 03, which is mostly what folks have been implementing and talking about until the hackathon, which is really good, which drove a lot of new feedback, mostly non-normative in nature, maybe completely non-normative in nature, actually. And we put out an 04 last night to capture those changes because there'd been a substantial number, and we wanted to make sure that we were all talking about the same thing with a checkpoint. In this presentation, I'm not going to assume that you've read 04, given that it came out in the last 24 hours. And it is my dearest hope that we meet our milestones. The working group has a milestone. It's April 2018 to submission to IESG of this protocol document. You know, people like to say, they told me it couldn't be done. And when they say that, they usually like air quote the they, like it's not clear. Like, I know who you are who told me it could not be done. And we can do this. So let's not, grab defeat from the jaws of victory here. We can pull this off. Okay. So regarding 04, like I said last night, an important thing to know is that it's wire compatible with 03. That is certainly not a requirement for internet drafts, that we not change anything, but I always view it as a really good sign that we are not fussing with the protocol components as much as we are fussing with the descriptions of those protocol components. So I am heartened by that. Hackathon, really awesome. Hey, hackathon was really awesome. See, when you cut off my thank yous, thank you, right? So it did create a real big burst of mailing list traffic. And Paul and I sat down, we tried to sort through it all, and we tried to capture that as of 24 hours ago into the document. Obviously, some judgments have been made there. So, read it and see if we, captured the essential items in a way that you can live with, because obviously there were sometimes disagreeing viewpoints on the mailing list, as well as, editorial quality issues to think about. But read it, and if it does not reflect something that, you think is suitable for consensus, raise the issue again, maybe in a new thread so that it's easy to identify that way. All right, next slide. Okay, so details in OR 04. In generally, it is much more succinct regarding applicability. I see Martin has sent a pull request since the meeting started, making it yet more succinct regarding applicability. And this is, I think this is generally a worthy goal, but reflects a tension the working group has been having about whether, more or less text is interesting. So where we had cases that enumerated a few use cases and enumerated a few positive properties, there was often feedback of saying, that's all true, but what about, yes, yes, and yes, it's good for the following things. And we were like, nodding and saying, yes, 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 that is true, but it really began to distract from the protocol work, and we were never going to be comprehensive about it anyhow. So we went in the other direction. We tend to generalize those concepts to say, it's good for the following broad classes of problems, period, write it down in, 15 words or something. I have a suggestion that if folks are interested in finding a venue, it may be the DOE working group, but though not this document, a document surrounding applicability and interactions with the rest of the broader ecosystem that may be well defined, but not necessarily elucidated on at length, might be an interesting piece of work to take on. But just separate it from the protocol definition. In any event, there is more clarity around error handling and DNS HTTP interaction. Again, I would prefer not to enumerate all the status codes that are already enumerated by 7230X. But the basic questions around, do you report errors? Which kind of errors get reported in which layers? And what does a success code versus a non-success code mean with respect to your DNS query? That seemed critical enough that I think we tried to address that head on. And obviously, if you don't think that's true, again, feedback would be great. Clarity around caching. There is actually perhaps some. This is a little less editorial. I think there are actually some good rules applied here to what to do in failure cases that weren't previously there. That is very helpful. Media formats. An important goal of this work is to support multiple media formats, but the document was using a hypothetical one to help represent some of this negotiation that could go on, and using a hypothetical format probably created more confusion than clarity. So it no longer does that, but it does stress to point out that there is a content negotiation mechanism available in HTTP, and media formats not defined by this document are still fit into this ecosystem. And there's a bunch of, capitalization changes. All right, so what I want to do with time here. On the next two slides, we've got the two issues that were open as of last night when I submitted these slides very late. Thanks to the chairs for being kind about that. But there's a lot of late moving action. So I think we should discuss those two slides. One is this issue about which methods are involved. And one is an issue Wes actually raised quite a bit of a while ago and hasn't seen a lot of action, but we haven't resolved. And I'm not sure there was consensus, although maybe it'll be easy now that we're all a little more comfortable with the protocol, about whether the one media type that is defined in the document is mandatory to implement or not. And then I think we have some time to open the mics to tell us what people think needs to be addressed before we put this thing into working group last call, because I would hope to do that within the next couple weeks. Okay. Issue 82. We've really opened 82 issues on this document. More, it's like 102 or something, isn't it now? Yeah. To be fair, some of those are pull requests, not issues. Method restrictions. So the current state in the document is that it defines what get means and how one replies to it. It defines what post means and how one replies to it. It does not tell you which of those you need to implement. Okay. There are valid use cases for get and for posts that the other method cannot satisfy, so they're not strictly overlapping supersets of each other. But in not all of those use cases apply to all environments. So I will summarize this. Post is more concise. It uses fewer bytes because it avoids the URI encoding issues. Right? It doesn't have a limit on the length of the encoding, which is often a problem for get methods, but probably is not a big one here. But our methods or our URIs are required to be encoded, and Oliver points out, those, if you put them in the URIs, they will end up in logs or can end up in logs, and there are, privacy issues around doing so. In favor of get is more HTTP cache friendly, and so if your implementation requires an HTTP cache to get performance here, and we've specified how that works, you won't be able to get that benefit. And that certainly may apply in certain environments, as well as there are limitations around the methods, which can be used in certain HTTP2 features, specifically HTTP2 push. Does not know how to push a post, but it can push a get. So if you were interested in that functionality, you would need the get method. I'm sure others will have comments on pros and cons, but that is my high-level sketch on what is valuable about each of those approaches. It's my observation that as you, as a developer, wander the internet looking for HTTP-based APIs, it is not uncommon for them to define a tuple of a URI and a method that mean different functions. So that may be one answer to this problem, is that our discovery question does not mirror the URI, it is a URI and method combination. On the other hand, mandatory to implement is indeed a very valuable property, which I will argue for strenuously when we get to the next issue. So I don't want to be totally hypocritical. I have an inkling of a recommendation, but I would actually prefer to open the mics before I go down that route, because I do not have a super strong viewpoint here. Oh no, I'd like to work on this, if that's okay.
The mic's back here. Oh, never mind. Oh, I see. Document authors, right. Hi. Mark Nottingham. I think unless you want to get in, and I suggested on the issues list a discovery document, solution, but I totally get that the working group doesn't want to go there. Unless you want to do that, then the obvious thing is MTI, and the obvious thing to say is servers must implement both methods. Or you choose one. And I know where I'd go with choosing one, but I reckon that would probably be more contentious than it's worth. So just make it servers have to support post and get.
So that's a stake in the ground for both, which is actually my inclination as well.
Yeah, I think that's reasonable.
Sorry, you're not pedantic enough. It's a stake in the ground for both for servers.
Yeah.
Mark said servers a couple times. Mark, if we said, oh yes, that's perfect, what would you say about clients, if anything?
Clients can use either.
Okay, right. Just wanted to make sure I didn't.
Is there a reason that clients should be forced to what? Try both ways and see which one they like best?
To implement both or whatever. Since you got up to the mic and you answered half the question, I wanted to know if you had an opinion on the other half.
I guess, you get to interesting places where theoretically a server could be using, like, let's say you deploy DO through a CDN or a reverse proxy, and the server really, really, really wants to use an HTTP cache. Do they redirect to a get, resource, which they can do, which is incredibly inefficient? But, maybe if they bang it into the head of the client enough, then they'll get the idea. Probably not, but, hey. Maybe you need some other way to signal that, but that seems more complex than this group is willing to do.
So what you just said was server, you have a preference for server must do both?
Well, let's be very clear.
On client.
I have a preference for get only, but I am realistic enough to know that the working group is not going to do that.
Yes.
Both,
Okay,
yes.
both for server, no opinion on client, on wording for the client. Yeah, okay.
Yeah, Martin Thompson. Yeah, you lost the slides, folks. Martin Thompson, +1 to both of those suggestions. Patrick gave enough reasons for one or other that I think we're just going to find that if you don't provide this service and servers, things will break. And we don't want things breaking.
So you're saying,
Both at the server, client picks at its discretion,
Right.
which means that the client gets to choose whether or not things cacheable, which is, yeah, suboptimal. It's not like you're going to be able to cache the post response, even though they are cacheable if you put the right header fields in there, but that's a terrible idea.
You made Mark.
make Mark go there, yeah.
Mark, why don't you
you
sit on the
talk
bench?
for a while, maybe Mark will go forward.
Daniel Kahn Gilmore. I think that both also make sense, and I think both make sense both for the server and for the client, and let me explain why. In the event that the server decides to redirect a post request to a GET request because they feel more comfortable serving a GET request, if we expect DOE to be a reliable DNS delivery mechanism, then what you're basically saying is that a client that only implements post is going to see this redirect and be like, oh, I don't know what that was, therefore it didn't work. And so if the expectation is that we want DOE to be, like if we want someone to be able to opt into DOE as their only DNS delivery mechanism, then you need to require that the client does both as well. If that's not the expectation of DOE, then I don't care about what, like, client can obviously ignore whatever it wants to ignore because clients can already ignore whatever they want to ignore. But if we expect that DOE will work as the primary or sufficient DNS delivery mechanism, then client has to do both as well.
Could you, excuse me, as a clarification, could you clarify what HTTP redirection method you think has the semantics that you want?
Like 302 found or something like that?
Sorry, what are the semantics you want?
No, I don't want these semantics. I'm saying a server might do these semantics.
So, yeah, so this is intriguing. I haven't quite thought about this, but when I do think about this, my inclination is your redirection, the scope of it is for a single transaction. That you're not going to be able to, like, essentially say, this is a new server over here, start using it. You're just going to say, you can find the answer to the exact question you asked over here. And that's probably not a mechanism anyone's like really that interested in doing, right?
I'll just say alt service. Mark Nottingham.
Say it.
Alt service. I think that's probably a horrible abuse of alternative services, but sure, why not? Because you can't mutate the path, for example.
Or the method.
Or anything, yeah. Yeah,
And it's off fail, but other than that, it's
yeah, sure. Yeah, it's full of nastiness, actually. It was asserted that post isn't cacheable. That's or can't be practically cached here. That's true. It's not. There's no standard behavior for caching post, but in fact, it's fairly common. My employer does it, for example, for some of its customers, and I make little grumbly sounds about that once in a while, and then I go away.
So this is a property, while we have tried not to highlight, we have kept in mind when reading the document. So if you think we are in violation of it, let me know.
No, I'm
Are you
making
suggesting
sure.
we highlight it?
No.
All right.
Can I finish? Thanks. I think what this is going to do is that some people are going to configure those patterns in their serving infrastructure, in CDN backend servers, and they're not going to. It's not going to be as easy for them to extend those benefits to other parties. So, for example, the client cache or another intermediate cache. Is that the end of the world? No, but just that is going to happen, and I think the DOE is going to encourage that behavior more, which is not optimal, but it's maybe the best we can do for now.
Yeah, Martin Thompson, I think there's a little bit of a confusion about what actually happens in the case that you get this redirect. I mean, it's not a scenario that I expect anyone to encounter because it's just two round trips for the price of one. But what happens is you get the URI you need and you make a GET request. This is just what you do when you implement HTTP. It's not anything that we need to talk about in this document, especially. I think this is the point of confusion here, where yes, you will be making a DOE request maybe to that new thing, but it's not necessarily even in the form of the GET request that we're talking about. Might not have this DNS equals base 64 in it. It might just be some random URL. So the server has already given the client everything it would need to act upon this. And so the client just blindly follows where the redirect goes, and maybe they'll get a 2xx response with a DNS.
Right. So I think for our combined cultures here in this room, what I've tried to describe that as is a 302 or 307 is actually a non-successful HTTP response code. It does not bear the DNS answer to the question you asked.
Correct.
You could call this a failure instead of non-successful, but that is so harsh. And it provides you, it is not a terminal failure because it provides you a location response editor that says, if you choose to go further and make another request and you look over here, you can probably satisfy your original question, right? Which is why we use the non-successful terminology. But, but it is a fail with respect to your DNS query.
Correct.
At that stage.
But it also serves to remind people that those people using, for instance, browser APIs to make these queries will find that they'll sometimes get back the answer anyway because the browser will follow them.
Right.
So my observation seems to be that we are reaching or have reached consensus on making, well, I understand, in the room. So perhaps as a term of art, that's not suitable, but that get and post for the server would be MTI and for the client would be either. And if anybody would like to argue against it here, we'd like to hear your comment right now. Otherwise, we're going to move on to the next issue. Okay. Issue number 48.
Obviously I've summarized issue 48, but it says that the document describes a reference to DNS UDP wire format as a media type, and the issue essentially asks, should this be mandatory to implement? Because obviously, wire format from RFC 1035 might not be like the most friendly minimal set one could provide to a JavaScript developer, for example. The draft says, this is fully expressive of what we want to be able to do, and it's important that we have something that's fully expressive, that we already have consensus around in order to get interoperability. So those are the arguments, and that is what it says in the document, but I am not claiming that there is consensus, but hopefully our chairs can declare so today. Modular the list, of course.
So as before, if you have an opinion that you would like to state on the mandatory to implement content types, this is your time.
My vote would be
Name.
for Stuart Cheshire from Apple. I would prefer to see this because as the DNS continues to evolve with new extensions, one that I'm involved with right now is DNS stateful operations. That may or may not be applicable in this case, but other extensions like that are going to be defined in terms of the current UDP packet format. And if that can be wrapped up and carried over HTTP, you have the option of that new functionality for free. If you do some translation, then you're left with writing new BIS documents every time for how you encode the new extension in this different way.
Ray Bellis, ISC. I think definitely yes, mandatory to implement. Per the comment I made on the list about an hour ago, I think it shouldn't explicitly refer to 1035 because the 1035 format is explicitly limited to 512 bytes in those messages. In fact, I'd argue for saying we shouldn't actually be calling it the UDP wire format, just wire format, because there's no reason why you couldn't put a 4K, 5K, whatever message. And I think we need a distinction between UDP wire format and TCP wire format, because ultimately they're just the same, but the TCP format has a little bit of framing on it, which we don't need. I mean, ultimately there is still a wire format, which TCP is an extension of.
So, I mean, I think we want to separate these issues, and thanks for the comment on both of them. Do you want to comment on the second?
So there's disagreement about whether 1035 says that the wire format
for UDP is limited to 512. So let's look at that. And if there, since there is now unclarity, I didn't think there was, we will write into the document, the 512 part doesn't matter here. So, all right.
I opened an issue for you. So I just opened an issue for that so that you have something to point at and remember. Martin Thompson, whatever Ray said was fine, and I'm just going to get up to say yes. At this point, I don't see any other rational approach to the problem, so just go ahead.
Hi there, this is Andrew Sullivan. So I think I'm with Ray about not referring to 1035 on this, just because not all of there's a bunch of other stuff that you're gonna end up having to refer to a whole bunch of other pieces if you're gonna do that. So I'm just.
Can you be specific, since we're only talking about the 1035 wire format? Which, are you thinking like EDNS?
Yeah.
Okay, but that fits in the 1035 wire format, and we're very explicit about that in the draft.
Yeah, I mean, I think you are. This was
For
more.
the HTTP people in the room, the way we extended DNS wire format will make you barf.
Yeah.
I mean, it was like, here, all of these, this part down here is defined this way. Ignore how it was defined and stuff fits into there anyways. But it turns out that it works.
So that's fine with me. That isn't actually what I got up here to ask, though, because I'm now confused about this discussion. What I'm reading in 04, but maybe I'm misreading it, is really that it's mandatory to implement for the server.
Oh, good call. I don't think that's technically true. So it does not mandate what the client sends?
Yeah, exactly. It doesn't mandate anything about the client. So if the client doesn't ever have to send this thing.
It does indicate, maybe not strongly, but the intention of the mandatory to implement format would be that if the client were to receive one of these packets, I mean, you can't force it to send much of anything, but if it receives one of these packets, it should need to interpret it. So you're probably looking at like the content negotiation run accept and the different ways that's done, right?
Yeah. So currently it's got this content negotiation, and it also says specifically the server must be able to process one of these, but it doesn't have anything about what the client should do. But of course, the client's never going to get one if it doesn't ask for it. Well,
this is, yeah. Welcome to my room.
So if the server is unable to respond, like this is just HTTP rules, okay?
Sure.
If the server is unable to respond with one of the content media types that was enumerated in the request, it has the choice of throwing a for mumble error that indicates that, or giving the answer it knows how to give. Like it is allowed to do that.
Ah, that's the part that I didn't know. Man, I wish we had this in DNS.
I'm sorry, I don't have enough fun for what you said.
Okay, so that was the part that I didn't know.
But I mean, I think actually the intention is that the client should be constrained by this if it's mandatory to implement. It should be able to read that.
Okay, so that
can be cleared up.
Yeah, that's not clear.
Because that was the intention.
Thanks.
Ola Emerson, yeah, I think the wire format without the UDP should be mandatory to implement. I would also love to have a minimalistic JSON for lightweight applications that want to talk to this. And I think the format that Google has today is perfectly acceptable for all of those, especially in the case when the application trusts the resolver. Whether we want to have another JSON format that is then all-encompassing, that will take us a few years to agree on, but that would be good too.
Yeah, I agree, that'd be a good thing. So the goal of this draft is to enable many media types to shine, and I think you should come back to the mic when we talk about chartering.
I want to ask the authors whether they believe that as a technical matter, extension to that particular sort of system where queries are not encoded as queries have their own query structure in the URL is technically compatible with this draft.
Yes.
Okay.
And if it's not, that's a mistake, but we went around on that, trying to make sure that was right.
Okay.
Yeah, Paul says they put some effort in on this one. Yeah, Martin Thompson, this actually raises the issue now that I opened at the start of the meeting while I was reviewing the draft. Thanks for putting out version 4. But the issue was probably lost in some of the discussion we had, and Mark's proposal to do the whole UDP templates and URI templates, pardon the mouthful. That got closed because it was part of the discovery thing. But in part of that discussion, there was a proposal made that would have made the process of upgrading to a different request content type easier. So the current format basically says that you've got this content type header field, content type parameter that's in the query. And you use that to switch what the rest of the query parameters mean. Presumably, if you wanted to go to something decomposed, you could have multiple query parameters, or as it is currently, you have a single one. The suggestion that was made was to overload the name of the query parameter with the semantics of the value. And that would allow you to do something like make a query, not knowing that the server supported the new decomposed format that has 15 query parameters, and also include as one of the query parameters DNS equals blah, and then you don't have to pay a round trip to get your answer, because the server that supports the new stuff can look at the new stuff, and the server that supports the old stuff can look at the old stuff. The only risk there, of course, is that you've made 2 requests and they might not be the same request. So go ahead.
So there's 2 issues with what you just said. I'm sorry, that was Martin Thompson. 2 issues with what you just said. One is that the answer that comes back might not have the same security properties if the response type, for example, doesn't support DNSSEC, which is very common in the JSON things. So might still be okay.
That's a response content negotiation problem, not a request content negotiation problem.
I'm sorry, request. So you might make a request in a format that's different than the response that you expect?
I don't see any reason why you wouldn't. I mean,
okay. I hadn't thought that
simple query might be, for instance, you might say, I just want a record for the following name. And if you devised a way of packing that into the query parameters, that would be a very easy way to make
even though you're saying that you would understand the full wire format coming back.
Right. Yeah. I mean, I'll take all of the extra RR sets you want to throw at me and all the eDNS options and the DNSSEC and what have you. But I like the simple format.
Right. So it's shiny. It's interesting. I think it's definitely not I think we have the minimal set that answers the question Ben asked. And so the question is architecturally, do we want at this stage, to do better? And I think your suggestion is better.
I'm putting you on the spot. I'm sorry, but
yeah. No, I'm looking through. I mean, I think there probably is some complexity, particularly in the description. I'm curious how well the room was able to follow what was going on there, right? Yeah, I'm just trying to decide the value in doing that versus what we have. I mean, do you agree that what we have answers the minimal question, that we enable new media formats that aren't described in the document?
What you have is fine. So there's some weird text in there about empty parameters and things like that, but I don't know where that came from. I'll send you a PR.
Yeah. I like my empty parameter, but if I'm in the rough, that's okay.
All right.
Why don't we do that on the list then?
Let's follow up.
Yep. So yes, it seems like again, so far we within the room we have consensus on this, and we will confirm that on the mailing list. And authors, please consider alternative ways to structure the query. I would also advise you to consider the implications of different query structures on the types of IANA registries that are going to be required.
And just to be clear, I'm sorry, I thought I was. Ray, we will chase down if there's at all a possibility that there was a 512 byte limitation, we'll make sure that goes away in this. Okay, great, thanks.
So now the question is, if we want to get to working group last call, what should we resolve other than what we've talked about today or, in the last 24 hours that aren't reflected on these slides that we've already talked about on GitHub or the mailing list.
Great. Thank you. There are some people.
Oh, there's.
Yes. That was actually a request, not pro forma.
There was nobody at the mic at the time.
Why a pizza?
Dough.
Joe?
That's what you get before pizza.
Kirsty Payne. I wanted to flag something about Section 8 security considerations, just regarding enterprises that want to defend themselves from malware that perform DNS lookups on the external internet. I can't see anything in the draft as it is about that. Since the DOE traffic will be indistinguishable from port 443 normal TLS traffic, enterprises would lose control over what DNS lookups their users could perform. Might be much harder to block or scan DNS lookups of dodgy domains for users. And the mitigation to that would be to TLS proxy everything, which is far more invasive than currently just proxying DNS and allowing your TLS traffic to pass end to end. So
The considerations, I actually don't remember if it was operational or security, it does make explicit reference to different DNS servers are going to give you, different answers, right? Which is, I think, at the root of your issue, right?
But maybe more of a detection issue for enterprises.
Maybe, I'm sorry, can you say again, maybe which should be there?
So maybe more of a detection issue for enterprises that currently look at DNS traffic to see where malware is making external calls to the internet.
Okay. DKG, were you coming up to answer that?
Yeah. So the draft, this is Daniel Kahn-Gilmore from the ACLU. The draft actually says filtering or inspection system. In the security considerations section, it says filtering or inspection systems that rely on unsecured transport of DNS will not function in a DNS over HTTPS environment. So I believe that addresses the concern. I'm not sure what's missing from that.
Or in specific, if there's specific words that you want changed in that, absolutely send them to the list.
Okay.
All right, thank you.
Great, thank you.
So the working group has one draft, the draft that was just presented, and the chairs intend to take this draft to last call on the list within the next few weeks, likely as soon as the known open issues have been addressed, which seems like it should happen fairly quickly. So if this draft goes through last call and is completed, and we find the working group without any drafts, we will immediately close the working group. So if you have anything else that you want to talk about, you must submit a draft before that time. Additionally, we would note that the deadline for asking for a working group slot is the 1st of June. So if we don't have any evidence that we're going to have anything to talk about in Montreal, then we will not have a session in Montreal, and the working group will be closed. So if you wanted to write a draft for DOE, that would be a good thing to know now. And if you want to write a draft, then we should consider whether your draft is within the current charter or whether it would require rechartering the working group. There are a few different topics that people have brought up as potential future work, but we haven't heard any volunteers to write drafts for those topics. And I've highlighted here a couple of sentences from one sentence from the charter that might bear on some topics of interest and might tell you whether the work that you're thinking about is in charter or out of charter. So at this time, I would like to solicit anybody who wants to tell us that they're interested in writing a draft. Otherwise, you have very few weeks before we are going to shut this thing down.
Question in the Jabber room. Would the JSON media type for DNS be within the current charter?
As only one half of the co-chair said, my opinion is yes, that we wouldn't need explicit rechartering in order to cover another media type. Yes, I believe it is. It would not require rechartering. I'm sorry that I was unclear on that.
This is Daniel Kahn-Gilmore. I'm not actually proposing a new draft. I just apologize for what I said earlier. I had a page down failure, and the sentence that I quoted earlier is in the operational considerations section, not in the security considerations section. So apologies for my mistake.
Adam Roach, as your area director, that surprises me. We would have to have a conversation around that. I don't think that was the intention when it was written.
Okay.
Eric Niger and Akamai, would something around end user client subnet equivalent cacheability be in scope for current charter? It seems like it might make sense. If this, and is anyone else actually interested in that, or is that something no one's interested in at the moment? That they could follow up with me offline on.
So you're talking about the interaction between HTTP caching and the internal, the contents of a DNS query, in particular eDNS
Right.
contents.
So eDNS Zero Client Subnet is something where if you wanted to have it be cacheable based upon that, would probably require, there's not a straightforward, obvious way to do that within HTTP semantics. So we would likely want to have something either here or in HTTP this, if that's something that people wanted to have a support mechanism for.
I think it might depend on the contents of the proposal. Okay. So certainly you could imagine proposals that are fairly aggressive and make changes in either DNS or HTTP, which would certainly be out of charter.
And I just want to again address Adam's point. The reason for my assertion was that the very first sentence of the charter for the working group is that this working group will standardize encodings for DNS queries and responses. So it seems to me that encoding a response as JSON would be right there in the first sentence. But again, he's our area director and we would review.
My HTTP this co-chair hat on, because that was speculated on for the last offer. That's really not suitable over there. That would be more about how a content server like a DO server, interprets the content. So yeah, it would need a different venue. I'm not exactly sure which one that is, but it's not HTTP this.
Ola Guðmundsson, don't like this. No comment. Ola Guðmundsson, two things. Yes, I'm interested in seeing a charter be in charter that people can specify JSON media formats. And to the prior gentleman's about the client subnet, just don't do it. Don't use that. If you have any further questions, watch the video of Bert's presentation at the DNSOft working group about the Campbell.
For a lot of you that may have missed DNSOft, quite understandably, the Bert Hubert of Power DNS gave a presentation on essentially how there is a lot of straw on the camel's back, and arguably it's already been the last one that has broken it. And so the added complexity of the DNS might be something that you're really trying to avoid. The one thing I'll ask for explicitly is that the topic of discovery came up a lot, both in the GitHub and on the mailing list over the past several months. And so that seems to be one that we're especially interested in if somebody wants to work on it. If nobody's going to work on it, that's totally fine. But to be clear, that is within scope. And if it's not getting addressed, then if it's going to be addressed, we really need to see something by June.
And in case the word discovery is a little bit unclear to anybody here, that's become sort of a piece of jargon in this working group. And to clarify, in this context, at least one of the things that discovery has meant is bootstrapping a connection to a DO server given only a domain name or potentially bootstrapping a connection given only an IP address. Okay. We note that there is no evidence of interest in writing a draft on this topic.
Well, no interest in coming to the mic at the moment. You gave us actually more than a week to do this, and some of us need to think about which of those we want to do. In specific, I might do a discovery one. I have an interest in it, but I also got the crap beat out of me when I brought it up the last time, so I have to decide whether I want to or not.
Yep. To be clear, I don't think, we're not talking about closing the working group until the current draft has completed all of the various machinations. So not just starting last call, not just completing last call, but the whole process for which the working group may be required.
This is Andrew Sullivan. So maybe though to chase what you've just been talking about a little bit, given that the question is not just is somebody going to write a draft, but also is the working group going to do anything with it? Since there was this fairly negative reaction to discovery or whatever we call it, is there any interest in the working group in working on that? Because I think that might inspire somebody to work on a draft if there's interest. But if everybody says no tomatoes, then I can't imagine that anybody's going to be that interested in it. I think we heard that a little bit in what Paul's reaction was. It's certainly my feeling as well.
This is Daniel Kahn-Gilmore. My understanding is that a DOE endpoint is defined by a URI currently. And if we're talking about a discovery mechanism that goes from a IP address to a URI, or from a domain name to a URI, this does not strike me as any sort of rocket science. And if someone wants to spend a little bit of time doing that to define this particular thing, we have a very clear input, we have a very clear output. This should not take a lot of time and should not involve a lot of Sturm und Drang, right? Well, something's broken if it does. This is a very simple mapping.
So my personal assessment is that there is quite a bit of interest in the working group in solving this problem. There are also quite a few people in the working group who don't particularly have interest in this problem, and there's quite a bit of opposition to specific approaches and mechanisms. So whether there exists a mechanism that would resolve the issue for the people who are interested and which would not encounter significant opposition, I don't know.
Yeah. The main point of this, as we wrap up this segment, the agenda was just to indicate that it's now or never. If you have more work for the working group, it's going to be the time to decide to do it. We don't expect you to commit right now in this meeting, but the deadline is visible. And so that would bring up DKG to give us a presentation on getting your DNS off the back of a truck.
So we should emphasize that we've now completed the DOE portion of your meeting today, and DKG is here as our inspirational speaker to help us think about things that we might do beyond DOE.
This is the part where I make everyone stand up and stretch and sing a song or something. I'm not sure. Yeah. So I actually presented this set of slides at the Hot RFC earlier this week. I really can't tell if this mic is on or not, but I'm going to assume it is, and people will tell me if it's not. So I want to talk about opportunistic use of DNS packets discovered opportunistically. So the thing that excites me about DOE is not so much that you can deliver DNS traffic over HTTPS by choosing your own preferred DNS over HTTPS endpoint, but that maybe we could get some DNS packets delivered when we weren't otherwise expecting them. and there's some opportunities there. So next slide, please. So currently, we have a whole bunch of different mechanisms here, right? You can just blindly accept that your network is giving you a good DNS resolver. You can pre-configure a standard resolver, which is not very privacy preserving. You can pre-configure your DNS over TLS resolver, or you can pre-configure your DNS over HTTPS resolver. Those last two are privacy preserving. But the common factors there are either I trust my network and hope that it's not spying on what I'm querying, or I trust my pre-configured DNS resolver. And so I want to ask, well, what if there was ways that we could get this stuff without having to trust anything pre-configured? So next, please, because pre-configuration is kind of a pain, and we don't know how to do that very well, and it means getting the user involved. There you go. So the question I want to ask is, like, would you accept a DNS record from this guy, right? So what if somebody just offers you DNS records at arbitrary times, and maybe there are some circumstances where actually it might be okay to use a record from this guy, right? This slide here suggests that, oh, this has got to be super shady. But in fact, in this case, if the A and quad A are signed with an RR-SIG, maybe you don't care that it came from some guy on the corner or the back of a truck, or some arbitrary DNS server that you talked to, and you didn't even ask it for the DNS records, but it said, hey, I thought you might like to know this. Part of the privacy concerns for DNS, for DNS privacy is about what are you asking for? If someone just gives you records and you didn't ask them for it, then there's no privacy loss, right? So next slide, please. So there's this idea of an opportunistic DNS over HTTPS that I find personally exciting, because I make a request to a server. I didn't pre-configure anything about the server. The server says to me, here's your HTTP response, and then via some sort of push-e mechanism, I'm waving my hands here because I haven't written this down in detail. It says, by the way, here's some other DNS records you might like to know. And I look at those DNS records and I have an option now as a client, right? My option is, here's DNS records. I can throw them on the floor like I would if they were, say, advertisements, because I run an ad blocker. Or I could bring them into my cache because I think they might be useful. Or I could inspect them, or I could think, oh, maybe they're in a special part of my cache. Anyway, I want people to start thinking about where can you use opportunistically delivered DNS records. Next slide, please. The reason I'm happy about this is because you get this privacy win where the client doesn't need to ask, right? It's like the library shipped you a box of books for free, and you can read any of them you like, and the library doesn't even know which one you wanted, right? So your library records there's no records in the library of like what records you requested. So you get a privacy win. You potentially can get a latency win if those records are useful for fetching sub-resources in an HTTPS context, or if they help you to resolve whatever the next link you click on is. And if there are clients that prefer to accept records that happen to have DNSSEC signatures, perhaps we provide an incentive for zone operators to sign their DNSSEC zones. So we might actually be able, if this mechanism exists and clients are incentivized to use records that are signed and more likely to throw away records that are not signed, then maybe we actually provide a little bit of an incentive to shift the ecosystem towards DNSSEC signed zones. So there are not a lot of opportunities at the IETF to work on projects that actually have 3 wins instead of pitting one of these various advantages against one another. Next slide, please. But the issue here is that where these opportunistically delivered records get used is really going to be heavily contextual. So if I'm an HTTPS client, like I'm a web browser, maybe I've got, well, like if they're signed, maybe I'm willing to use them, right? But if they're not signed, then I'm not. But maybe it depends on if I'm an HTTP browser or if I'm a SSH client or something like that. There's different risks for me for using them. And so I think that this kind of work, I'm presenting this here at DOE because I think this work is sort of a follow-on from DOE, but I don't think that DOE is the right place to do this work, because I think the right place to do this work is going to be in the working groups that represent the context that we're interested in. So, so if we're talking about should an HTTPS client choose to accept these opportunistically delivered records or not, that maybe belongs in the HTTP BIS working group, or maybe in WhatWG or potentially some other place. But I want us to think about the opportunities that this brings. And the other question that hopefully we'll be asking there is, I mean, I've got what are the risks for bad data up there, right? That's how you make the decision about whether these records are acceptable to be used, right? We don't want arbitrary cache poisoning to just be accepted. Next slide, please. I think I've got one more. So I just want people to start thinking about different clients. So the web browser is the obvious one. There are other HTTP clients. The TLS DNSSEC chain extension is an opportunity for any sort of TLS-based client. That chain extension can ship a bunch of records to you. Again, they kind of fell off the back of the truck because they came in via the TLS handshake. Or maybe there's other users of the DNS that might be interested. And so I'm here as an inspirational speaker to encourage you to think about where else in the IETF you do work that could potentially make use of these, and think about whether you want to start to define ways to accept these things just because they didn't come in off of your pre-configured thing on port 53 doesn't mean that they're not necessarily valid. And we have an opportunity to get all of those wins at once. So there's a mic line forming already. I think that's it for my presentation.
Mohit, thanks. So how do I distinguish, maybe I trust responses from you signed or not, but maybe I don't trust responses from some other XYZ website, which I am visiting over HTTPS and is sending me, trying to poison my cache in some way. And as a user, maybe it's either way is a bad option. So if the browser decides it for me that I trust this and this responses from this and this companies, and if you leave it to the user, then he's also left in a limbo that he can't decide, right, whether I should trust this or not.
So leave it to the user we're back in the pre-configuration soup, right? Where we have to ask the user some complicated question that they really don't understand and that they can't answer. So I agree with you that would be problematic. My question is, can we think about situations where you might as well try these packets anyway? Right? Well, you might as well try to use this data anyway. And I agree with you that cache poisoning is a real risk. So I don't want to encourage just promiscuous use of opportunistically delivered DNS traffic. But if you know that you're going to, as an example, you're an HTTPS client, you get an opportunistically delivered DNSSEC signed record, so you can tell that it actually comes from the correct zone, and you know that you're only going to visit that site over HTTPS, so you're going to validate that whoever has the control of that site has a PKIC certificate in the first place, then why do you care where you got the record from? There's a situation where you've got this validation over here and you've got this other validation over here, and the path by which the record was delivered to you maybe doesn't matter. Now maybe we can shave off one of those constraints and you're still okay with using it, or maybe we can't, maybe you need them both. But I want to encourage you to think about the situations that you might have to get that latency win along with the privacy win. And I think that's an exciting opportunity. I agree with you. I don't want asking the user at each point, do you trust a record from this particular place?
I guess we are far from draft yet, but I already see a must here. It must be signed.
It might depend on the context, but I agree with you that in some contexts, yes, must be signed is absolutely required.
Dan York, and maybe I just haven't had enough caffeine, but I'm struggling a little bit on, could you give some precise examples of where you're excited about seeing this used?
I'm using a web browser. I'm not actually excited about using web browsers in general, but let's pretend I'm excited about that.
Pretend you're excited about
using it. So I'm using a web browser and I visit example.com. And example.com says, I would like you to fetch a sub-resource from example.net. And by the way, here's the IP addresses for example.net.
Okay.
And maybe, let's leave it at that for now, right? So now I don't need to do another DNS lookup.
Gotcha.
Right?
Okay.
I don't need to have anything pre-configured. I don't need to talk to my local network. I've got an IP address, and I know it's going to be an HTTPS sub-resource, so maybe I'll just go try the IP address that was listed, and if they've got a PKIC cert for it, good enough for me.
Okay, that's helpful to understand. Thanks.
Hi, my name is Andrew Sullivan. I think this is an incredibly good Back to the Future moment because, of course, in the old days, before I could spell IETF, the DNS just did this for you, right? It'd have data and it'd kind of stuff it into the additional section. Hey, here's a thing that I know. You might as well take this too. And we learned, I think, pretty early
that was called poison. It was
That's
dangerous.
why I said, I don't want this to encourage poison.
So the problem that I see here is that if you actually want to do these things, and I actually think that I can think of lots of examples of stuff that I would want to do with this. But if you actually want to do this kind of thing, we are well past the point at which the camel from DNS Op the other day has collapsed and entered the tent, and every other camel analogy that you can think of, because really what you're talking about now is a new kind of protocol, a new naming protocol, an identifier thing that has the properties necessary in order to do this, and grafting. We figured out, okay, we're going to shove DNS into this HTTP thing, and now we're going to make it do a bunch of extra DNS stuff in the back end in order to put signed records in the additional section, I guess. I don't know. And once you start doing that, it's pretty clear that actually you've got a different protocol. And rather than, bolting more bolts on the top of the side of the bolts, we could stop and have a harder look at what we really want out of a protocol here. We could use DOE as a kind of bootstrapping protocol to get you into something else. And that to me would be a more interesting way to go than this. Thanks.
Can I do a brief response on that? So in the example that I just gave to Dan's question, I don't think we need any other machinery beyond what's in DNS and DOE today to do that. No. We have a specified DNS chain query that says how you say, and I would like the chain with the response. Those pieces are there. Now maybe the camel is staggering under them, but the pieces are there.
So it is convenient that I am at the front of the line.
Patrick, if I can just also address, there's also, besides, the HTTP mechanism where you also, in order to do this type of pushing down data, you would have to associate a question with the data. But mostly if we're looking at a DOE server as a resolver, this is already something you're trusting your resolver to do on your behalf. You're trusting that you're going to ask the same source that you just asked for example.com, that it's going to give you an answer for example.net as well.
So thank you for this presentation. So I call this concept, still looking for a pithy name, I call this out-of-band DNS, or out-of-band naming. And, for the non-HTTP nerds in the room, HTTP actually has a few mechanisms that do request routing in ways that you might think were traditionally reserved for the DNS, but HTTP defines for itself. And those definitions tend to be restricted to the origins that produce them or the connections you've already established, right? So we have origin frame, we have alternate services, we have some coalescing rules in 7540 that do things to your routing if you think, that an HTTP client always resolves the DNS name and connects to the IP address that pops out of that chain. That's not always what happens. And this is in many ways a natural extension. And I think the use case that you've drawn up here is actually something that HTTP should take a look at, right? Because it is about how HTTP decides where to get its information. And I think it's super powerful for the reasons you illustrate. People have heard me kind of talk about this in the past, going back, I think, to when we were in Seoul. It's clearly out of scope for this working group, and I don't think this working group would be right even if it wasn't out of scope for us. I think in an HTTP context, it's an HTTP decision. But I've been planning to work on this and now collaborate with DKG going forward. So I would love to hear from other people that are interested in that. The timeline we're talking about was, something, quote unquote, something in Montreal. Now that something could be a BOF, it could be a bar BOF, it could be a rant at a plenary microphone. We'll see what form that really takes. But if you want to be part of that process, please reach out. And then, because I'm already grandstanding, I will say the two major technical topics I look at when I look at this, other than the fact that how it relates to HTTP routing, are first category is how do I know it's safe to use this address, and that is some kind of a signature. In the case of TLS, we already have some kind of a signature, and that also secures the transport layer, which is in between HTTP and the addressing anyhow. So that's like a feature you really require. But the second category of stuff is trickier, right? It is how do I know this is the endpoint that this name would have wanted me to use if I had looked it up for the authoritative for this name, right? That's harder. I think there are some answers around that, but I think that's actually the really interesting question, to explore. And so I think that's what the work should do.
David Skenazy, Apple. I find this cool. I'm going to make 2 points. One is, I'm going to start with the negative one. So first off, this is cool. I think the really benefit would probably be for like a social media site where kind of everything they post is websites like Reddit or something. And here are a bunch of links and here are the addresses with them. I could see real value there in saving the latency. If you click on a link, you've already preloaded the DNS. The negative point is a lot of people use DNS for load balancing to the right data center based on the source address. So if the Reddit is somewhere closer to a data center that's not the one that's closest to you, you could end up getting routed to the wrong one.
Yep.
So,
I think that's specifically the last point that that Patrick made as well, right? I think you guys are coming into convergence there. Yeah.
So we need to figure that one out. But let's take that aside, and I'm going to propose something crazy of using this without any signatures. And hear me out. Because having these signatures sound great and everything, but that kind of requires DNSSEC support everywhere.
It requires people to sign their zones, yeah.
And it requires the clients that support it, and that might take a while. So how could we do something useful without DNSSEC? And the answer is happy eyeballs. What you can do is you feed the addresses into an asynchronous networking API. The idea being, once the user clicks on that link to example.com, it'll start doing the one connection to that IP address.
HTTPS example.com?
It absolutely requires TLS.
Okay, just making sure.
And it'll also kick off DNS queries to its usual resolver. And as the addresses come in, it feeds those into the list and kicks off those TCP connections and those TLS. And you end the happy eyeballs once you have one established TLS connection. And that means you can actually use this. There are some privacy considerations. You may need to disable SNI or something. But I think we can make something really useful out of this without the dependency on DNSSEC.
Thanks.
Hi, my name is Shane Kerr. So I like the observation that, well, I believe that we do need DNSSEC. So I like the observation that when you have DNSSEC, then you can trust a lot of stuff that you don't currently gain access to. Sort of in crypto, we trust. And actually, once we got DNSSEC, how you got the data all of a sudden became irrelevant. We don't need the root server system. We don't need the hierarchy. We don't need any of it. We just need the data, right? So that's kind of cool. I think it's maybe a little bit optimistic to say that you can actually trust it. Other people have already pointed out things with load balancers and actually where the question comes from may matter, other things. There may also be all kinds of timing attacks that may be possible. I can pre-populate someone's cache and then I can see that they're coming quicker than they would otherwise and be able to identify them and things like that. So interesting, but I think there's issues. I do really think that Andrew Sullivan is probably on the edge of correct, which is that
just the edge.
He had a
just the edge.
correctness adjacent statement, I guess, which is that, yeah, maybe it's time to reconsider that we've just hit the limitations of DNS as a protocol. And now that we're looking at carrying it over HTTP, we all of a sudden find all this freedom and all these areas we can explore. So maybe that's what we need to do.
Ray Ellis, IC. I also fully believe that DNSSEC is required for this. And I think, I believe you know this full well, Daniel, but for those, it wasn't said well at the start. You can't just use the RRSig. You've got to have the entire chain of trust. Yeah. An RRSig is not a standalone signature. You've got to have the whole thing. And if you're 4 or 5 levels down, that means you've got to have 4 or 5 levels of DNS keys, and the RR6 are all of those, the DS records are all of those that prove that there is actually a chain all the way to the root. And you've still got to have that root key as well to be able to trust all of that. And as far as I know, the eGNS chain option is not yet standardized. I'm not even sure if it's adopted.
It is actually standard. I believe there's an RFC for it.
Full RFC for it?
Right. The best kind of standard. Right. Thank you. Yes, point taken.
Brian Gondwana, when I joined the queue back there, obviously the conversation had gone nowhere down this path. And it's a bit like those flat threaded forums where it's hard to tell what you're applying to. Poison. We work with poison all the time. Chemists work with poison all the time. You contain it. I see a lot of cause for using this data for that particular request. I don't see much value in populating your local cache for a longer term. You're getting back, in your example, a web page that contains some links that you want to then follow the DNS lookups for. The only reason it doesn't contain the IP addresses instead directly is SNI. So what you're doing here is getting a hint that changes the name to an IP address on the links that are in the content of the page you're looking at. So long as you're using this data in that context only and not caching it for other things, your poison is contained. Your poison is only the poison that you're already being offered. So you don't need, just to reply to the last couple of people, you don't need all these signatures if you're not sticking it in your cache, because the poison doesn't poison anything else.
Thanks. So Mike Bishop, Akamai, I will point out that that's not entirely true, because once you open the connection, then it's a persistent connection to that name. And new requests that come in from other documents could then go over that connection. Kind of. But I also want to note another use case about this that excites me a little bit. So we have, as Patrick alluded to, alt services in HTTP, and we have a new draft on how to put alt service in DNS, which means now when somebody serves you a link, they can also pre-populate the information that, and the server supports Quick.
Jim and I have our own correctly sized mic.
Who are you?
Oh, sorry, Warren Kumari. Good, and I do still have a Jim behind me. So I happen to think that this is a grand idea. In fact, I happen to think it's a grand enough idea that Wes and I wrote a document about it in DNS Up. However, not everyone else thinks it's a particularly grand idea. So I think that there should be really good coordination with DNS Up to find out why, etc. Because people had some really good ideas, and we kind of got sidetracked and did other stuff instead.
Yeah, so I agree that this is the sort of thing that probably requires coordination, cross-working group coordination. But I will observe that the contextual framing that I have here points out that the actual authority for this probably resides in the contexts where it will be used, because it doesn't actually make, this idea doesn't make any claims about how the DNS itself should operate. It says, how would you use DNS if you got it in context X or context Y?
Jim Reid. Daniel, that's a nice idea, but I wonder if you've thought about some potential denial of service attacks that this would expose the end user to. For example, if I'm a bad actor as the server, I could be sending stuff down to the client saying, validate this stuff, and the validation just gets out of control and just keep punting out lots and lots of predictive DNS data, which you think the client might be interested in, but all you're really doing is making life difficult for the client by making him do all that validation work. I think that would be a potential problem.
I totally agreed. I had not thought about that particular form of denial of service attack, but like anything where the server can ask you to do work, I would hope that clients would implement their own rate limiting and actually, tell a server that, I'm done with these, or just ignore them once it's been obviously too much.
Mohit, I haven't thought this through completely, but I wonder what happens with phishing. Now, of course, you can still do phishing detection on the client side, but now I visit some website and I already have the addresses of all the phishing websites, and I don't even have to look them up anymore. So, and they are still signed. You can still register them, get certs and everything. So does it make it harder somehow? That would be something to look at least.
So I think that's sort of the similar concern raised about the security considerations, right? If the way that you're defending yourself against phishing is that you think you know all of the DNS queries that your clients are looking at by monitoring their DNS queries in the clear on the wire, you're kind of out of luck. And I agree with it that if that's your model for defending against phishing, this makes it worse.
Hi, this is Puneet Sood from Google. I have one, I'm channeling the DNS camel talk a little bit in my question. So these are all the benefits. So have we also put some thought into the the overhead and the cost of implementing this versus the benefit we are getting here?
I mean, I haven't directly implemented this, so I haven't put the kind of thought that I think is warranted into implementation. But I don't think the implementation is the real cost. I think that the additional costs are the issues that people have been raising here, which I'm grateful for, in particular about the consequences to anti-phishing mechanisms that rely on clear text DNS and the cost to people who rely on the DNS for load balancing. I think those are probably the biggest concerns maybe that this would arise. I don't actually think that implementation-wise this is particularly complicated.
One thing I can think of from the implementation side is now you're introducing stronger coupling between the HTTP servers that a website might have and the DNS servers they run. Traditionally, they are run separately. Now you're introducing significant shared fate between them.
Yeah, I don't think we have done a good job as a community of documenting what we think that separation gains us. So I recognize that we have had that separation historically, forever, but it's not clear to me that we have a clear model of what that separation is, like what properties it's supposed to have, and what we think the security, efficiency, what we think the trade-offs are involved in that. So I would, if you're someone who believes that that separation is particularly critically important, I would love to hear more details about specifically why it's important and against what particular threats. And if you want to collaborate on a document that tries to describe the benefits of that, or maybe the lack of benefits of that, I'd be game to talk it over with you.
Sure, thanks.
Eric Nygren, Akamai. I'm not sure I have a good answer here, but I think one of the things that this goes to some questions that folks were saying earlier is between the various combinations of things we have going across both this working group, but things going on in DNS op and HTTP base, and between kind of where DNSSEC versus PKIX is going, and where alt service versus connection coalescing versus this discussion versus a few others. Like we're quickly seem to be getting to a point where like the camel's standing on its own back. And
it's just made out of straw.
Yet going through some multi-dimensional space is like, is there a point at which we need to start looking at this kind of outside, like wondering whether the working group boundaries is starting to become a problem here, and we need to take a step back and say architecturally, independent of kind of how the working group breakouts are going on for this, where do we want to go on this? What is kind of our operational model, security model, how everything ties together model for this, so that we have something that people can understand rather than this really complex pile of all these different things could happen, which is going to be really fun for all the people who want to take advantage and exploit it, because there'll be lots of, I'm sure there'll be lots of bugs in there in whatever gets implemented.
I was hoping to raise conversations with this talk, and I wasn't expecting them to go to the actual fundamental structure of the IETF, but I agree with you that we do a decent job at analyzing things in isolation and a not so decent job at analyzing things in conjunction, and that there's a risk, yeah.
Suzanne Wolf, but taking off DNS op chair hat, flinging it wildly across the room, and speaking for the, as described. Jason Polis, I haven't looked into this for a while, with this use NS records to provide the IP address of the HTTP server being used.
If that's a question about my proposal, I think the answer is no, because the question seemed unrelated to what I thought I was presenting.
Paul Argumason. So Dan, you have had a few metaphors thrown at you here. So we could say that if we say you're working on this on reliability or expediency, you have to deal with the poisoned happy eyeball. But the thing is that using this, we might even be able to speed up the web or the applications, because the traffic can be pushed through this. So yes, I think this is interesting. So I'm going to ask the room a question instead of you. Anybody willing to work on implementations? Talk to me. Well, let's start talking about how we can push this through an HTTP2 tunnel.
And Patrick also specifically said he was interested in working on this and called for people to.
So let's talk at the break.
Suzanne again is myself, still with DNS op hat flung into the corner. if you're going to pursue this, per some of the conversation in the chat and at the microphone, it might be easier if you concede at the beginning that you're not really talking about DNS. This is context sensitive and does other things with identifiers in ways that DNS just doesn't. So if you come up with something else to call it early, it might be easier to talk about it.
I'm going to jump right in front of Mark just to observe also that there has been an ongoing effort for identifying the different ways we use names on the internet to identify endpoints and how to connect to them. And so there's some cross-pollination that goes on there that if we're not talking about the DNS, you know, what type of identifiers are we talking about and the connections therefrom? Yeah.
You can talk about domain names if you want. DNS is not the only protocol that uses them. Just please, it makes people nervous when you call it DNS.
So I mean, there's been several comments saying maybe this shouldn't be DNS, but I have to say there's a lot of nice stuff in DNS, and it's really tempting to just take advantage of it. So I mean, I'm talking about piggybacking. You guys are talking about straw on the camel's back, but like it is definitely like the DNS has produced a lot of really good work. And there's interesting functionality in it. And so to say, fine, do this, but don't piggyback on the work that we've done, like, sorry, I'm really going to be tempted to piggyback on it.
Mark Nottingham, it's Thursday afternoon, so I'm hitting my IETF week exhaustion limit. But just to amplify what Patrick said, you know, this has been discussed in the HTTP working group on and off for a long time. Ever since HTTP2 was started, this was kind of a back thread where we knew this was an area we'd want to explore. It just not yet. It's from the interesting thing to me was the hands that were raised in the room when we were asking about, or when it was asked about implementer interest. I mean, if you want to ask for time in Montreal, if you're coming to Montreal, I think that's entirely justifiable. I'd encourage you to do a barb off and have a side conversation, and you know, let's start talking. Yeah. Well, if it's in the HTTP working group, you don't need a buff for that.
Plus, there's beer at a barb off.
Yeah. Well, in your barb off, my barb offs are cocktails.
All right. Paul Hoffman, I want to disagree with Suzanne. I am not uncomfortable with you using the word DNS. DNS means a couple of things. Those of you who are familiar with the DNS know that we have a DNS terminology document, which actually is now trying to describe the public DNS. That's still open and will be open for a little bit, but not for very long. I think you are doing the DNS here because you're using, assuming that you are using, the reason you're here in DOE is this might be done over DOE. That uses the DNS wire format, it uses all of our naming, and you might stuff this into a local DNS cache in the web. That's the reason why you're getting these records is not so you can use them immediately and then forget it, because there isn't any immediately. You might actually cache them. So you might cache them in a way that is appropriate for a DNS cache. Golly gosh, there's a TTL in there. You might follow the TTL. This sounds a lot like DNS modulo no port 53. And so you might want to call it DNS plus something. We called this DNS over HTTPS. You might call it DNS over HTTPS plus push or whatever. But I think calling this DNS, if it's what you had described as early, which is, you know, DNS semantics, DNS caching, et cetera. Sure, that sounds very DNS to me.
David Summers Harris, Rockton. So just a little name suggestion. I really like Patrick's suggestion of out of band names. By spell it NOOB, if you wanted to go with that.
I would actually call it in-band names because it's actually in band with the communication that you've already done. So that's where the confusion, I think, comes in.
So Paul just said something that makes me want to take the big circuit breaker and switch the working group back on for a second. You said that DOE could populate the local DNS cache. Is that in scope for this work? Because that seems, we had discussions around that, and I thought the conclusion of that was, no, that's out of scope for our use cases.
I don't see it out of scope for the use cases. I don't think it's in scope either. It is something you might do. So DOE, according to the charter and to the document, lets you send a query and get a response. It doesn't say what you do with that response. And so there's many things you can do just in the same way. Ignore DOE for a second. You are something that can connect over port 53. There's lots of things you can do.
Or 853.
Or 853. There's a lot of complaints that we are doing too many things already, but yeah, so.
Sure.
Yeah.
I'm not one of those.
Yeah.
I'll do a small clarification and Patrick, I think, wants to address.
Right, okay.
So there's a difference between, I want to use Doe for my web browser, and I want to use Doe for, my local resolver natively, implements Doe. To a random piece of software somehow populates the DNS cache without the knowledge of the DNS resolver with Doe. That's weirdness.
That sounds really weird.
If we're talking about populating a DNS cache that will be used by someone who doesn't know what the security policy is.
Exactly.
Then all of these contexts that I'm trying to highlight in this presentation are null and void because we've lost the context.
And when we don't want to go there. That's all I want to make sure.
So that's why I'm saying I think that we need to think about this specifically in terms of the context in which it will be used, in which case caching is in scope. If we're saying we're going to populate a random DNS cache that might be used by arbitrary other things, I think that's crazy town, and that's where the poison's danger is.
Right, this isn't, what the reference Mark was worried about wasn't Crazy Town, it was the recursive resolver case, where you are obviously trusting your recursive resolver, and the application may cache that data, and it may use those TTLs, in that data for the application's own purposes, and that was the extent of the scope there.
All right, well, the goal was to get people talking, and it seemed like we had a good discussion, so thank you very much.
What? Do you want to address that last thing?
I wanted to. So thank you all for coming to Doe. This completes our session. Please sign blue sheets. My apologies, we got those out a little late because of the AV confusion. But please make sure to sign your blue sheets and have a good day.
Thanks. Ben does, right there. Right in front of you, yep. Thank you, Mike.